Hello, algebra students. Mr. Lawrence here, and after today's video, you'll be able to say I can factor by the GCF grouping and by the difference of squares patterns. And you'll also be able to say I know when to factor by GCF grouping and difference of perfect squares. Very important stuff, being able to recognize when to do what. All right, now I made this little chart here, and this chart will get longer because we have a couple more types of factoring to learn. But for right now, it's good. It'll serve us very well. And our green areas in here are the go areas, meaning we have this type of factoring, GCF, greatest common factor. If there's two terms, should I GCF? Yep. If there's three terms, absolutely. And if there's four terms, absolutely. I would highly recommend writing this chart down into your notes. Okay. Now, if we're trying to group, can we group with two terms? No. Can we group with three terms? And can we group with four terms? Of course, that's when we do group. The difference of perfect squares pattern, that I'm going to refer to as DOPS. Two terms, yes, but must have one negative sign, right, for it to be a difference of perfect squares. Okay. Three terms, difference of squares won't work, the DOPS won't work, and four, the DOPS won't work. Hold on one second, I seem to have lost my recorder. Okay, so I'm going to show you how to use this chart. I'm going to come down to this problem number one here, and I see there are three terms, and I know right off the bat I've got to try GCF. Now, I should have tried GCF anyway, and we can't assume that three terms means only GCF because, again, we're going to learn some different types of factoring. But this is a three term. I'm going to look for the GCF, and so I'm going to look for the GCF of 4, 8, and 32, and I believe that's going to be a 4, right? And then I need the GCF of x cubed, 8, excuse me, x cubed, x squared, and 5. Well, the lowest exponent is 2, so it's going to be an x squared. So I am going to factor out a 4x squared from each term of this trinomial. And so I'll have a 4x squared times the quantity of 4x cubed divided by 4x squared would be a plain old x. Minus 8 divided by 4 is 2, but the x squareds cancel. And then 32 divided by 4 is 8. X to the fifth divided by x squared is x cubed. Right? There you go. All right. Now here, there's two terms, difference of squares. But remember, GCF also has two terms. So I'm always going to do GCF first. So I look for the greatest common factor, and I believe that is 25. I'm going to pull 25 out. Going to get an x squared and then minus 4. Now, I'm not done because look inside the quantity. I still have two terms and a subtraction sign, right? You see that? Two terms and one subtraction sign. So I'm going to ask myself, is x squared a perfect square? It sure is. Square root is x. Is 4 a perfect square? Yep, its square root is 2. This is going to factor. 25 is going to come down. Then I'm going to go with two quantities, x plus a 2 and x minus a 2. And there you go. Now, some of you might be looking inside those quantities to see if they can factor further. I'm glad you're looking there, but no, they're done because we've already GCF'd. We only have two terms. We know we have to have one negative sign, so that excludes the x plus 2 quantity. So I go to the x minus 2 quantity, but the x is not a perfect square. Neither is the 2, so we are done. All right, number 3, there's 4 terms. So I'm going to go to grouping. Now, you're not going to find a GCF amongst all 4 terms, and that's how I know to go to grouping right away. Now remember, grouping is just GCF in disguise. We're going to GCF 3 times. So I group my quantities. Uh-oh. Oh no, this will work. This will work. I thought I goofed, but no, this is okay. I want the GCF of 6xy and 14. Well, I think it's just 2. And so I'll factor out a 2, and I'll be left with a 3xy and minus a 7. Now I need the GCF of 4x minus 21y. Oh, I did goof. Look at that. I don't have a GCF, do I? Now remember that to be able to group, I have to have a GCF in both groups. So I need to rewrite this problem so that I can have a GCF in both groups. And I'm just going to scooch it up a little bit to give myself more room. All right, so I'm going to rewrite it as, let me see here, I think I'm going to put the 6xy with the positive 4x, and then the negative 14 minus the 21y. And I'm going to group this way now. Excuse me there, I had to sneeze really quick. I put a plus in between. Now I go looking for the GCF of 6xy and 4x. Well, GCF of 6 and 4 is 2, and the GCF of the variables is just x. So I pull a 2x out, and I'm going to be left with a 3y plus a 2. And then I find a GCF of 14 and 21y, noticing that both are negative. So I'm going to pull out a negative 7 from both. So I'm going to get rid of this plus and pull out a negative 7. And then I'm going to get 2 plus 3y. Some of you are thinking, uh-oh, we don't have matching quantities. Sure we do. Aren't 3y plus 2 and 2 plus 3y the same thing? If you want, you can rewrite that 3 plus 2, 3y plus 2 like that. Now notice that 3y plus 2 is common to both groups, so I am going to pull it out. I'm going to divide by a 3y plus 2 and divide here by a 3y plus 2, and that'll be in a quantity. Then I'll have a 2x left, and from here I'll have a minus 7 left. And there you go. Okay. Number 4, there's 2 terms. Let's consult the chart. I could GCF or difference of squares. Well, GCF first. Looks like 7 is the GCF. So I'm going to pull a 7 out. Have an x to the 4th minus 1. Now hold on one second. I'm going to run out of room here, so I better move this problem 6 down. Control G. Just give myself some room to work. Okay, now I'm looking inside the quantity. I still have 2 terms, and I do have a subtraction sign. So I'm going to go looking to see if I've got perfect squares. Well, is 1 a perfect square? It sure is. The square root is 1. Is x to the 4th a perfect square? Yep, because x squared times x squared is x to the 4th. So now my problem factors like this. 7 times x squared plus 1 times the quantity of x squared minus 1. DOPS always factors that way. Now, I'm not done. This first quantity here, this x squared plus 1, there's 2 terms. Can't GCF, already did. No subtraction sign, no minus sign. It's done. But this one has 2 terms and 1 negative. If x squared and 1 are perfect squares, this guy factors further. Square root of 1 is 1. Square root of x squared is x. Yep, this factors further. I've got a 7. I've got a quantity of x squared plus 1. Nothing happens to those 2. But this one breaks down to these 2 groups, x plus 1 and x minus 1. By the way, you'll see something like this as a bonus on the test. This shows me that you really are a master of factoring when you see a problem like that, but it'll be done at the bonus level. Okay. So, problem number 5. It looks like I'm going to try to GCF first. None of my other problems involve a trinomial. Other types of factoring, that is. What's the GCF of 8, 24, and 32? Well, I think it's 8. What's the GCF of x to the 4th, x to the 5th, and x to the 7th? Remember, take the smallest exponent. The least exponent is what we want. X to the 4th, x to the 4th. So we're going to have an 8x to the 4th out front. 32 divided by 8 is 4. X to the 7th divided by x to the 4th is x cubed. All right, 24 divided by 8 is 3. X to the 5th divided by x to the 4th is x. 8 divided by 8 is 1. X to the 4th divided by x to the 4th, they're all canceling, so I'm just going to have a minus 1. Now, we don't know how to factor in trinomials other than by GCFing them yet, so we'll stop right here. All right, going to jump down here to number 6. I have to move this number 8 down a little bit. It's in my way. Not literally the number 8, Mr. Lawrence, the whole problem, number 8. There we go. Just move him down. Okay, looking at 4 terms, I'm going to go ahead and group. I'm going to rewrite it so that I definitely have a GCF. I like to go 5x plus 5z. And then I'm going to go plus xy plus yz. And I really like this because notice how I have x and then z, and then I have an x and then a z. That's a good thing. It's going to line up pretty nice. Okay, so we're going to group the first two. Going to group the second two. Always grabbing the sign to stick a plus between my quantities. Going to GCF right here. Looks like it's going to be 5. Pull that 5 out. Be left with an x plus a z. That does not look like a z. Sorry. It looks a little bit better. All right, going to GCF here. Looks like the GCF is going to be y. So I'm going to pull out a y. And I'll be left with an x plus a z. Notice both quantities match. Let's pull it out. Let's divide by x plus z in both terms. X plus z there. So I'm going to get a quantity of x plus z and 5 plus y. Okay, number 7. There's 2 terms. Remember, always try GCF first. I'm going to pull out a negative 6. Trust me on this one, it'll be a lot easier. When that lead term is negative, I'd like to pull it out if I can. All right, negative 6 times x squared minus 9. Now, looking inside the quantity, I have 2 terms and subtraction. Are they both perfect squares? You bet your boots they are. 3. The square root here is x. So I'm going to get negative 6 times the quantity of x plus a 3 times the quantity of x minus a 3. This blue one broke up into these 2 quantities, just like I might break up, let me see here, something with only 2 factors, 6 into 2 times 3. That's all I'm doing. Where did I get the 6 from? I just made it up to show you how I prime factorize that. That's what I'm doing to this x squared minus 9. Okay, number 8. 2 terms. I see a GCF of negative 1. Pull out a negative 1, and I'm going to get x squared plus 9. I look in here, I've got 2 terms. Both are perfect squares, but there's no subtraction. I am done. There is nothing more I can do to that problem. Okay, finally, problem number 9. It's a trinomial, which means I have to try to GCF. Is there a GCF other than 1 between 3, 4, and 5? Nope. Do all 3 terms have x's? No. Do all 3 terms have y's? No. This one cannot be factored, and we are going to say that it is prime. Has no factors like other than 1 in itself. Like 7 is a prime number. The only 2 numbers that I can multiply to get 7 when I'm considering positive natural numbers are 1 and 7. That's it. This expression is prime. Okay, that's it for your video for today. Mr. Lawrence signing off. Good night, everybody.